Hello everyone, this is the periodic table made simple with Miss Rodriguez, and today we're going over everything you need to know about the periodic table unit in high school chemistry. Today we're going over three things, so metal versus nonmetal, periodic table periods and groups, and periodic trends. But first, let's talk about Mendeleev. Why was Mendeleev so important in the creation of the periodic table? He discovered the periodic system in 1869, which is where he put elements in order of atomic mass. Notice that he did not put it in order of atomic number. Once he put his periodic table together, he noticed that there were certain patterns with the elements as you go down the periodic table. Because of these patterns, he was able to leave gaps for elements that had not yet been discovered. And not only did he leave gaps for these elements, he was also able to predict the properties of these elements based on the other elements around them. So based on the patterns that he was already seeing across rows and columns on his periodic system. Now let's talk about the different major areas of the periodic table. First, we have the metals, which are hard, shiny solids. They're good conductors of electricity and heat. They're malleable, meaning they can be formed into thin sheets. And they're ductile, meaning they can be formed into wire. Metalloids are going to have properties of both metals and nonmetals. Nonmetals are mostly gases at room temperature. If they are solid, they are dull. They're poor conductors of electricity and heat, and they're not malleable and not ductile. Here we can see where the metals, nonmetals, and metalloids are on the periodic table. You'll notice that the metals are mostly in the bottom left corner of the periodic table, and they take up the majority of the periodic table. Most of the nonmetals are in that top right section, and the metalloids follow this staircase shape right in between the metals and the nonmetals. The only exception is going to be hydrogen. So hydrogen is a nonmetal, but it's the only nonmetal that's on the left side of the periodic table. So it's here in the top left. Rows on the periodic table are also called periods. There are 7 periods or 7 rows on the periodic table. The period number of an element tells you how many electron shells it has. And as you move down the periodic table, the periods are going to get longer and longer because it's going to take more electrons to fill those larger shells. For example, if you look at row 1 of the periodic table, you have hydrogen, and hydrogen only has 1 electron shell. If you look at row 2 of the periodic table, you have lithium, and lithium has 2 electron shells. If you look at row 3 of the periodic table, you have sodium, which has 3 electron shells. Columns on the periodic table are also called groups or families. The element in each group are going to have the same number of valence electrons. And as a result of having the same number of valence electrons, elements in the same group or family are going to display similar properties and reactivity. So they're going to look and act alike, just like your family. If we focus on column 1 specifically of the periodic table, you'll notice that each of these elements, so the elements in column 1 would be hydrogen, lithium, and sodium, they each only have 1 electron in their valence shell. And their valence shell means their outermost shell. So only 1 electron in the outermost shell. There are 5 important periodic families that we need to talk about, and those are the alkali metals, the alkaline earth metals, transition metals, halogens, and noble gases. First, let's talk about the alkali metals. The alkali metals are in group 1 of the periodic table. This is going to be your most reactive family. They have 1 valence electron, and they form +1 ion, meaning in order to make themselves stable, they need to give away that 1 valence electron to another element. The exception to this rule is hydrogen. So even though hydrogen is in that first column, It is not part of the alkali metal family. It is not a metal. In group 2 of the periodic table, you have the alkaline earth metals. These are slightly less reactive because they have 2 valence electrons, meaning they would have to give away their 2 electrons in order to become stable. And when they do give those 2 electrons away, they end up forming +2 ions. Our next group are the halogen, located in group 17 of the periodic table. They're reactive, but not as reactive as the alkali metals. Remember, alkali metals are first, making your halogens the second most reactive family. They have 7 valence electrons, which means in order to be stable, they need 1 more valence electron. When they gain that final electron, they end up forming -1 ions. The noble gases are located in group 18 of the periodic table, and these are inert gases, meaning that they're non-reactive. The reason they're non-reactive is because they have full valence shell. So full valence shell usually means 8 valence electrons. The exception to this would be helium, which only has 2. And these elements do not want to gain or lose any electrons. They are already stable the way they are. Transition metals make up the middle and bottom sections of the periodic table. A lot of these are more like the metals that we expect. So things like gold, silver, titanium. Some of the transition metals, especially the ones at the bottom, are going to be radioactive. Now let's talk about our exceptions and we understand what makes them different. So hydrogen and helium are both exceptions on the periodic table. They are the only elements on that first row or that first period of the periodic table. Because of that, they only have 1 electron shell. So the maximum number of electrons they can hold is 2. Hydrogen is going to behave a lot like those group 1 elements because it wants to get rid of its electron. But it's not a metal, it's hydrogen gas. That's why it's not part of the alkali metal family. Helium has 2 valence electrons, but just like the other noble gases, it also does not want to react. What makes it different from the other noble gases is the fact that its full valence shell is 2 valence electrons, not 8. So again, quick little overview between the groups and the periods. So groups are your columns, periods are your rows. Groups are going to have the same number of valence electrons. Periods are going to have the same number of electron shells. Groups are going to have similar physical and chemical properties. And as you go across a period, the atomic number increase as you go from left to right. Now let's go over our 3 periodic trends. So first we have atomic radius, which is the distance from the nucleus to the outermost stable electron. If we look at our periodic table here, you see that atomic radius increases as we go down the periodic table, which makes sense because what did we just say about periods or rows of the periodic table and the electron shells? The lower down you go in the periodic table, the more electron shells there are, so the bigger the radius of your atom. Atomic radius also increases as you go to the left of the periodic table. The reason for that is because the more negatively charged electrons you have, the closer they hold onto that positive nucleus. So the smaller the atomic radius as you go to the right of the periodic table. That is until you add that additional electron shell. So again, increases as you go down because of the increase in electron shells, increases as you go to the left because there are less negative electrons on the left side of the periodic table than on the right side of the periodic table. Do some atomic radius practice. So I'm going to ask you some questions. I want you to pause the video and answer before I show you the answer. Based on the arrows for atomic radius, which of these elements have a larger atomic radius? Magnesium or chlorine? Magnesium, because it's more towards the left of the periodic table. So they're on the same row, but magnesium has less electrons on that outermost shell. It's not holding as tightly to the nucleus as chlorine. Oxygen or tellurium? Tellurium. It's on a lower row on the periodic table, meaning it has more electron shells. Neon or lead? Lead. It's farther down on the periodic table and also more to the left. Next, we have electronegativity, which is the ability of an atom to attract electrons and form a chemical bond. Notice that the arrows for this are the exact opposite of atomic radius. So electronegativity increases as you go up the periodic table, and it increases as you go to the right of the periodic table. The only exception are the noble gases. So the noble gases, which is the last column on the periodic table, have zero electronegativity because they're stable. They don't need to attract any electrons. They already have a full valence shell. That means the elements that most want to gain electrons are going to be the ones with the higher electronegativity. So a higher ability to attract those missing electrons. So again, let's do a little bit of practice. Pause the video before I show you the answer. Which of these elements do you think has a larger electronegativity? Chromium or selenium? Selenium. Selenium is way closer to having a full valence shell than chromium. It's way further to the right on the periodic table. Oxygen or polonium? Oxygen. Oxygen is much further up than polonium, so it's much closer to being able to fill that valence shell. Helium or fluorine? That's a trick question. Helium is one of our noble gases. It doesn't want to gain any electrons at all. In fact, fluorine is actually your most electronegative element on the entire periodic table. Our last periodic trend is ionization energy, which is the energy needed to remove an electron. If you look at the trend, it's the same arrows as our electronegativity arrows. So increases as you go up the periodic table, increases as you go to the right of the periodic table. The only difference here is that the noble gases are actually going to be your highest ionization energy elements. And that's because it's going to take a lot of energy to remove an electron from a noble gas. It already has the perfect number of electrons. It's already stable the way it is. So it's going to take a lot of energy to remove those electrons. Out of the entire periodic table, helium is going to have the greatest ionization energy. Not only is it a noble gas with a full valence shell, it only has 2 electrons. So it's holding those 2 electrons very close to its nucleus. All right, our last set of practice problems. Which of these elements do you think have a larger ionization energy? Again, pause the video before I show you the answer. Nitrogen or bromine? Nitrogen. So even though bromine is closer to the right, nitrogen is higher up on the periodic table. Rho matters more for all of these periodic trends. And that's because nitrogen is holding its electrons very close to its nucleus. It only has 2 electron shells. Strontium or xenon? Xenon. So xenon is one of those noble gases. It's going to be very, very hard, so it takes a lot of energy to take an electron from a noble gas. And lastly, silver or sulfur? Sulfur. So sulfur is further to the right and it's also higher up on the periodic table. So sulfur is going to take more ionization energy. All right, everyone, that's everything you need to know for the periodic table unit in chemistry. Thank you so much for your time. Let me know if you have any questions in the comments below. Please make sure to like this video if you found it helpful and subscribe if you don't want to miss any of my future chemistry content. If you're a chemistry teacher and you would like access to this exact PowerPoint, I do have it on my TPT store, Chemistry Made Simple, as well as worksheets, labs, and activities for this unit and all other units in high school chemistry. I hope you have a good day. Bye!